Welcome back to another exciting chemistry lesson. In the previous lesson, you copied the 3 graphs, and the purpose of titration is that we can use pH to identify the equivalent point in order to calculate the initial concentration of the unknown sample that we work with. For example, if I give you a sample of an acidic solution, what's the molarity of that solution? We don't know. But using titration, we can figure that out, and that's the main purpose of titration. Now let's go back down here and look at this graph right here. We have a polyprotic acid. Poly means many, and product refer to proton. And when we talk about chemical reaction, proton is basically H+. So as you can see here, at this point right here, right before each equilibrium, we have this point. That point, you have the equivalent concentration of whatever the initial acid it is going to be equal to the conjugate of it. As you can see here, 3, it lost 1 proton, and here you have 2 proton, lost 1, and here you have 1 proton, it lost that last one right there. So you have to memorize at a specific point and what happened. So before each equilibrium point, you will lose the whole entire proton. Now let's go back up here and look at the very basic graph right here. Here you have this graph. This graph right here is a strong acid versus a strong base. So I will put strong acid plus strong base. And up here, what you have here is a weak acid versus a strong base. So I will call WA, okay, plus strong base. So think about this. When you have equivalent in terms of strength, what is the number of pH, or at what pH the equivalent point? It will always be at 7. And then you can see that at that equivalent point you have the volume. See, that's the beauty behind this. Once we get the pH, we can measure using a pH meter. We can get the volume, and we also given the molarity as well. Okay, and that's the key thing. Remember in the previous lesson we talked about N. In this case, we don't really worry much about the M and N. We worry about this part because we can set this in terms of equivalent, and we can solve for the molarity, and we're going to show you that next. Now in addition to that, we also need to remember or memorize what happened at a specific point. At this point, again, halfway between the equivalent point, that you have pH equal to pKa for weak acid with strong base. Okay, you have to memorize it. Of course, since we are titrating with a base, the exit OH will be determining the pH, which right here would make sense because right above 7 we have pH, which right here we know it's getting basic. That now everything, and you also know that at this specific zone right here you have a buffer zone, which means you have to use the Henderson-Hasselbalch equation. So this right here you have to use the Henderson equation. Okay, we will talk more about that when we talk about buffer, but for now you have to realize what's happening here, because you are going to require to label a specific part of the graph. And once you reach your equivalent point, again, you can still use this equation right here. See that? So every time you have an equivalent point, you use that equation to solve for whatever concentration of the acid. And once you pass that equivalent point, what is going to be the one that determines the pH? Come back together. So again, you have to know what's happening. Initially, you have your solution of acid, titrate with a base by adding specific volume, and you can measure the pH. Eventually it reach halfway, and then you have your equilibrium point. Halfway, 40-20, right? So right there you have pH equal, and they ask you this question all the time. They're going to put in a multiple choice. They're going to ask you about the concentration and the pH in terms of pKa. Okay, and again the same thing at equivalent point. You have the base in terms of OH equal to the number of moles of acid. We have the paragraph to summarize the graph. Here you have your acid plus a base. This produces the conjugate. So this is the conjugate base. This is your acid right there. And here you have your base. And this is your conjugate acid right here. Okay, so keep that in mind. We learned that a long time ago, but remember conjugate pair. And then again, we have different situation. The equivalent point is the point where the OH equal to the number of moles initially present. When we have a strong acid and strong base, equivalent is always at 7. A weak acid and strong base is always above 7. Okay, and one thing we had to realize is that when we do your titration, there's a color change. Okay, there's a color change, and it has this light pink. What happens when you put too much of the base. Now you are going to have an error in your calculation. So if you add too much, that would increase the concentration of your acid. So keep that in mind, okay? It makes sense because this equivalent point allows us to figure out the concentration. Now let's go back down here and look at a problem. You have a weak acid of 50 milliliter. Okay, I forgot to write that down. With a known molarity is titrated, and using a pH meter we can measure and we graph it. And the base, this is a strong base right there. Calculate the concentration of a weak acid in the original solution. So up here we know is a weak acid and a strong base. We're going to use this graph right there. We can see that right there, and this pH is about 9 something. It doesn't really matter. What's important is right here. Okay, so what we have here is, going back to this basic equation, MV. Okay, let's label this acid and base. How about that? So I know my M. No, I don't for my acid. I'm trying to figure that out. But I know my V. I have 50 milliliters, so 50 right there. Okay. For my base, I know my molarity is 0.1. My volume, how much volume did I use? Ooh, look at that. Going back up here, a 40 milliliter. See that? So we have 40 milliliter. There you go. So just use a calculator. 0.1 times 40. Okay. Divide by 50. We have 40 times 0.1, or 0.1 times 40 equal to, we know the answer, and then we divide it by 50. There you go. And this gives us 0.08. So the molarity for the acid is 0.08. There you go. Let's try another problem. Here we have a 50 milliliter, okay, I forgot to put 50 milliliter again, of strong acid of a known molarity. Again, we're trying to titrate it so we can find the molarity. And the same process, okay? I just changed the story a little bit. But in this case, because it is a strong acid which reacts with a strong base, we know we're going to use this one. In most cases, they will only give you one graph. In this case, I make it more tricky because I gave you two graphs. As you can see here, 40. Okay, same thing. We go find the equivalent point. You see how equivalent point is where it's slanted straightforward like that? That's where the equivalent point is. It won't give you the equivalent point on the graph, but you have to know. You see where it's halfway like that? See, that's the equivalent point. So it's halfway through that way. Okay? So in this case, what do we have? The same process actually, MAVA equal to MBVB. And it is the same value, so therefore we expect to have the same answer, 50, right, 0.1 times 40. Of course, MA equal to 0.08 molarity of HA. There you go. See that? And it doesn't matter what graph, if it's acid titrate or base titrate and acid, it's all the same process. Okay, we are going to use the same equation. Now let's look at this one where we have, as you can see here, we have a base titrate by a strong acid. Again, when we have an equivalent point at 7, okay, that tells you it is a strong, in this case, a strong base titrate with a strong acid. Where right here we have a weak base titrate with a strong acid. You see that? How do I know? Well, remember, when we look at the pH scale, 7's right here. This is 14. This is 0. This is acidic, right? This is basic. As you get lower and lower, it becomes more acidic. It makes sense because at the equivalent point, you will have lower than 7 because, again, we have a weak base. There you go. See that? So the solution overall would be more acidic. Okay? So the same thing, you have to identify the specific location, what's happening here. Right here, you have in terms of pOH. See that? Because we're dealing with a base, pOH. And here we're talking about the initial base present equal to the H plus produced. Okay? And here you have the exit conjugate base. The same thing. We have the base produce a conjugate acid right there. Okay? Conjugate acid. And here you have an acid produce a conjugate base right there. So you have to understand this process and familiarize the whole entire concept in terms of what's happening during the titration, because they're going to ask you in terms of multiple choice. And here I have the summary again, equivalent point. We have equal concentration in terms of mole as well. When you talk about concentration, it's also in terms of mole. That's a very important thing you have to remember. This is also mole, okay? Because they are working in the same solution. And of course, you can find the total solution. It will be there for you. And the same concept right here, okay? And that's the whole entire logic of titration. The hardest part is memorize what's happening in specific part of the graph and able to apply this equation up here to solve for your unknown concentration.